For anyone who doesn't know me already, my name is Claire. I'm one of the TAs at Launch School, and I'm also a student just over halfway through the Ruby track, so I'm now on the front end. So let's have a little look at the introduction. So what are we going to cover today? So this is the first workshop in a series of introductory workshops about Git and GitHub. Now, it doesn't matter if you only attend one of the three or two of the three, whatever. They build on each other a little bit, but if someone misses this first one, they'll be fine in the second and third. And if you miss the second one, you'd be fine in the third. So they do go together, but it's not essential that you attend all three. So today we're going to just look at Git and just see how to use that and what version control is. And then next time we will look at GitHub, and then the third one is just a bit more advanced Git stuff of branching and staging and undoing stuff. So the third one is my favorite. And then, so what are we going to do today? So it's a beginner's guide to version control using Git. So we're going to learn what Git is. We're going to see how to set up configurations, creating a Git repository, making an initial commit. And then the last two are going to be tracking changes to a single file and then tracking changes to multiple files. And those are the reasons that we use Git, is to track changes. So if you have any questions as we go through, please put them in the Q&A. If they go in the chat, they can get a bit lost, whereas I keep an eye on the Q&A and I'll try to answer them as we go along. If they're related to what I'm talking about in the moment, I will try to address them straight away. Other questions that can be left till the end, I'll leave till the end. And then there'll be time at the end for further questions as well. And I will post a feedback form as well. I'm going to do that now. So anyone that needs to hop off early can grab that and fill it in. But for everyone else who's still here till the end, I will paste it at the end again. I would really like everyone to fill that in. It's really useful to hear what works and what doesn't work so well. And I've made several improvements to workshops based on feedback. So, we really are listening, and it's really helpful to hear your experiences of working through these and whether you're coding along or just listening, if you like the quizzes, if they're too easy, too difficult, all those sorts of things, really useful for us to hear back. So as I said, it's great if you can code along, then go ahead. Don't worry if that doesn't work for you. Some people find that a bit distracting. It can be hard if you've only got one screen. And I'll be using multiple choice quizzes throughout. So it will keep things interactive even if you're not coding along. Those quizzes, they're just for fun. No one's recording the answers. They're anonymous. I can't even see who says what. So just take part in them. It's all part of the learning experience. Now, on the left-hand side, you can see AWS Cloud9, and this provides a website where you can program. So you don't have to install lots of software and everything. You just go on this website and it creates an environment where you can program. Launch School recommend this environment because it's easy for users. And when people are sort of all on the same thing, it's easy for us to support. But if you have your own environment that you prefer, then it's fine to use that as well. You don't have to use Cloud9. It's just the one that we recommend and the one that I will be using today. So let's have a look at what is Git. So Git is one of the most common source control management systems used by software developers. It's an incredibly powerful tool, and there's a lot going on under the hood. Now, to become a Git master would take significantly longer than an hour-long workshop, but you only need to know a handful of commands to be able to use it sufficiently to get much of the benefit from it. So first of all, what is source control management? So it's keeping a historical record of files and the changes made to them, who made the change, when, what, and why. And that's called version control. It's used to track and manage changes to software code. Now, many of you may have done something like this yourselves. You create a file, like a Word document or something, and you want to make changes to it, but you also want to keep a clean version in case the changes you make don't work out. So you create a copy of the file and you make changes on that copy. Now, if that new document is rubbish, you can just throw it away and you just go back to the old one. But if the new file is good, you might archive the old one and then future changes will be based on the new one. And Git is used to implement exactly that for code files. So it tracks and manages changes to the code base so that if a mistake is made, developers can turn back the clock and look at those archived versions. And they can also, you can have multiple developers working on the same files at the same time and integrate all the changes back together into a single code base. So it's really useful. Now, unlike some other source control management tools, Git is distributed. So there's no central repository. There is no single point of truth. If you've all got Git repositories that you're sharing, they all have equal standing. And that's where GitHub comes in, because GitHub enables you to create a single source of truth. And that's something we'll be looking at next time. So that's the one that everyone goes to. That's the one that's got the most recent version in it. That's what I'm looking at. And that's what GitHub provides. But it's important to know that Git, the tool, rather than GitHub, the website, Git, the tool, is just creates a version control management system that is distributed. So everyone is of equal standing. Now, if you're using Cloud9, Git should already be installed, and you confirm this by running Git and then a -v to get the version. This tells me I've got Git version 2.3.9.2. For other development environments, if you're not using Cloud9, you just follow the instructions signposted in Launch School's Git and GitHub book. And if you've got any difficulties in installing Git, just reach out to us in the Slack forums. There's one specifically for the prep courses, so that would be a great one to start. And we're a really friendly bunch. People like helping each other out. So go in there and ask for help. And then another Slack channel that is good for beginners is one that's for the prep courses. So again, if you're having problems with any of the course at all, and if it is installing stuff or actually stuff in the curriculum, the prep course Slack channel is the place to go. And it's just good to get involved with the community. Now, back to Git. So there are applications for using Git, such as GitKraken and SmartGit. I think there's loads of them. These provide pretty graphics to show what's going on, but under the hood, all they're doing is issuing commands on the command line. Therefore, understanding how to interact with Git using the command line just removes the mystery of those tools. So that's what we're doing today. And actually, I don't use any of the tools. I just use the command line. I just like the transparency of knowing what's going on, but some people prefer the tools because they're a bit more visual. Obviously, whereas the command line is just text. Now, throughout this workshop, I'm going to use the word repository, or repo for short. And this just means a collection of folders and files that contain the code for our software project. So it's just a fancy way of saying the collection of folders and files in there. That's a repository. So before we move on to using Git, let's have a quick quiz of the theory we've just learned. Now, remember, just give these your best shot. No one's recording them. It's all anonymous. And then at the end, we'll go through the answers and move on to the next thing. So I'm just going to launch that now and give it a go. Okay, I'll just give another 30 seconds or so. If I'm not giving enough time for these quizzes, please put something in the chat and I'll give a bit longer for the next one. It's hard to judge because I don't want people sitting there twiddling their thumbs, but I don't want to unnecessarily rush people either. Okay, so let's have a look at the answers there. Just going to share those results and then move over. And then here are the answers. So for the first question, so does Git provide a central repository? No, it doesn't. It doesn't provide this single source of truth. It's distributed. So everyone's repositories on their computers are all equal standing. There isn't a central place. And the central place that we want is something that GitHub can provide, which we'll learn about next week. So it's just important to know that Git does not provide a central repository. When you have a central repository with Git, it's not been provided by Git. Second question, SCM is the abbreviation for source control management. That's true. VCS is the abbreviation for version control system. So it's not a version code store, it's version control system. And the last one, who created Git? It was Linus Torvalds, who also created Linux. Brendan Eich created JavaScript, and Yukihiro Matsumoto created Ruby. Okay, so well done. It's good to warm up with that quiz. So on to the next one. So where are we? Let's get Git set up now. So we've learned what Git is. Now we need to set it up. Something has gone a bit wrong. Can I move this? Hold on a moment. Figure Git to include the details. Sorry about that. These notes have gone a little bit squiffy. Right. That's meant to go here. Right. Here we go. So, oh dear, I shouldn't have done that or that. Here we go. Right. So, configuration data tailor how Git responds to specific commands. So providing your name enables Git to record your name against the changes you make to the repository. And there are three types of configuration settings. There's system-wide settings, and these apply to all users and all of their repositories. And to set those, you use git config and then _ and system. There's then user-specific settings that apply to all repositories. And they override the system-wide settings, but they're specific to the user. So if you've got several people that log onto the same computer, they can just set their own settings for the repository, so their own name. And to set those settings, you use git config with a global flag. And then lastly, you've got repository specific settings. So they override the system-wide and the user settings. And so there'll be settings that are specific to the particular repository that you're in. And to set those, you use git config local. Now, most of us are just using our own computers. And so we use the git config global to set git configurations so that all of the repositories we've got on our machine have all of these settings, our name and our email. So we don't have to change them, or when we don't have to change them lots of places, keep them up to date if we're having them repository by repository. We don't need system-wide ones because we don't have more than one person working on our computer. So let's set this up. So we are going to set our name and email address to the changes that we make. So to use this, we use git config. Oops. Git config, and then we're going to use the global flag. And so I'm going to set my user name, so it's user.name, and then I just need to put my name in quotes. So git config because we're setting the configurations, the global flag because I'm going to set them for all of my settings on my computer, username because we're setting the username, and we're setting it to Claire McCady. Well, you shouldn't set it to Claire McCady, obviously. Right, and then the next one we're going to do again, so we'll do git config, we're going to do global again, and this time we're going to do the user email. So this time we don't need quotes around this, so I'm just going to put claire@awesome.com. Here we go, so we've set our name and our email address, so every time we make changes, this name and this email address will go against those changes. So if somebody needs to get in contact with us because they don't understand what we did, they'll know who we are and they'll know how to get in contact with us. Now, the last thing we're going to do before we create a Git repository is set the default name for the primary branch. We're going to talk about branching another time, actually talk about it in the third workshop. But basically, the primary branch is the one that we're going to be making changes to today. So when you first install Git and you create a repository, the default name for the primary branch is master. But GitHub expects it to be called main, and that can cause a problem. Now, I'm not covering GitHub today, but we just want to start out by aligning Git with GitHub to help us in the future, to help our future selves. So to ensure Git names the primary branch for every repository that we create, to ensure it calls the main branch main, by default, when we create it, we're just going to set that again with this global flag. So we do git config with the global flag, and then init, so initialize the default branch. So initialize default branch. And we just want to say main. So this is just making sure that that primary branch that is in every repo that we create on this machine is always called main, just to help us when we start using GitHub later. We don't need to worry about that ever again. We've done it once, done, brilliant. There's no quiz for this section because setting up the configurations is generally something that you only have to do once. So you don't have to memorize all of this. You just need to know where to look it up when you need it, such as Launch School's GitHub book. And therefore it's not magic as to where it's getting this information from. We've put this information in there. That's how it knows who we are, and that's how it knows what our email address is. So now we've set everything up, let's create a Git repository. Just checking there's nothing fatal at the bottom. Okay. So to create a new repository, first we'll need to create our code file. So we're going to create a new directory for our project. So I'm just going to call this mkdir to make a directory, to create a new directory, and I'm just going to call it Git Basics like that. So mkdir, all that. I'll put a space there. There we go. So if I go in here, I've probably got two folders. No, I haven't. Yeah, I have. I've got that one. Just ignore that one. So this is the one that we're using. This is the one that I've created. This is just the file tree here. So we are going to move into that one. So I'll call it Git Basics. So now we're inside that directory, our new project directory. This is where we're putting all our code files. Now we need to create a couple of files that we're going to put in there, ones that you should always have before you create a Git repository. So I'm going to use the command touch to create the file, and the first one is called README, like that, and then the second one is license. So the README file is generally where you put information about the project and what's going on and how to use the files and things. And then the license is where you explain who is able to use this and those sorts of bureaucratic things. But before you create the repo, you should always have these two files. It's just convention to have them. And then the third file that you should always have is a gitignore file. Now, the gitignore file lists files and directories you don't want to be included in the Git repository. So they're files that will be in your project directory, but Git isn't tracking the changes to it. And so things that you might not want Git to track changes to are things like databases. Every time you create a new record in a database or delete something, you don't necessarily want to record all of those changes. And so databases are a common one that you might want to exclude. So let's create a gitignore file to do that. So touch to create the file, and then .gitignore to create the gitignore file. We go over to the file tree here. I'm going to Git Basics. You can see gitignore here. Now, if you followed along and you can't see gitignore, it might be because you've got this unset. So if I unset that, I can't see this git ignore file. If I go in here and do show hidden files, it then appears. So the dot just creates a hidden file. And all that is hidden files, ones that are used to store information that you don't want people to change easily. I mean, you can see that it's not that hard to get hold of it. You just change the see hidden files, but it's a convention thing that's showing you that, you know, you sure you want to mess around with this, because this is a hidden file and it's something that you might not want people to change easily. But that's fine. This is our repository and we can change everything. So we've created the git ignore file. I'm going to open it up now. And I'm going to tell it to here, I'm going to tell it to ignore all git repo, ignore all SQLite databases. SQLite. Like that. And then in order to do that, I can list individual files. I can list whole directories. So I don't know if I want everything in a particular directory, like everything in the database directory, I could list that. And I can also use wildcards, and that's what I'm going to demonstrate here. So we imagine that we've got a directory called DB for databases. And then inside that, any file that ends with SQLite 3 is something that should be ignored. So that asterisk there, it's just a wildcard. So it's just saying that all files that end with that extension that are in the folder DB should not be tracked by Git. So the files will be there, but Git won't have any knowledge of them or what changes are made to them. So I'm just going to save that change and close the file. You can see my prompt here goes a little bit squiffy because I'm zoomed in and Cloud9 is a bit uncomfortable with that. So I'm just going to clear the screen. So to recap, we have created a project directory called Git Basics. We then created 2 files in that directory called README and license. And then we created a git ignore file in the top of the project directory. And within it specified files in that database directory with the extension of SQLite 3 that we don't want to be tracked. Now, these 3 files should all be included in a projects directory before making a Git repo. It's convention. If you don't do that, you'll still be able to create a Git repo. Nothing bad will happen. It's just convention, and it's good to get into these good habits when you start out. So now we've done all the things that we should do. Let's create the Git repo. So to do this, you only need to make sure that you are in the top of your project directory. So you're not in any of the subdirectories within it, and you're not above it either. You've got to be in the top of it. So we are in Git Basics. We can see that from the prompt. So this is where we create it, and we do it simply by doing git init. So initialize git init, and that's it. That creates a repository. It said initialized empty Git repository, and there it is in Git Basics. If we go into the file tree, we'll be able to see what has happened is this .git file here has been created. That is where the Git repository is. That's where all the changes are recorded. It's just folders and files in there, but we don't need to look at it. And this is what the Git tool is using. So conceptually, this has turned the Git Basics directory into a Git repository. And to undo that, all we have to do is delete this .git folder. If we delete the .git directory, all of the code files are outside of that will still exist in their latest form, but we will lose all of the history of the changes that we've made to it. So be sure that you want to do that before you do it. But, you know, if something goes wrong or you change your mind, you don't want it to be a Git repository anymore, or you created it in the wrong folder, just delete that file and you can go back to where you were before and create it in the right place. So 2 words of warning: don't run git init within a subdirectory of the directory you want to make a Git repo. I've said that, do it in the top level. And then secondly, don't nest Git repositories. So I shouldn't create another folder within Git Basics and then do Git init within that, because then I'll be nesting my Git repositories. Now, this isn't like Ghostbusters of crossing the streams and the world will end, but weird things will happen. And so the version control won't work as it should, which then makes it pointless to do. So just don't, when we say don't nest your Git repositories, all it's saying is that if you're already in a Git repository, don't create another one inside it. Okay, so let's have a look at the commands that we have learned by doing another quiz. So have a go at this one. Okay, I'll just give another 15 seconds or so. Okay, so let's have a look at the answers. So for the first question, to make changes to configuration settings, you need to use git config, which everyone got, excellent. And then to create a new Git repository, you just use git init, so that initializes a new one. And then what files should be included in a project's directory before you create a Git repository? All of them. You should create a README, a license, and a git ignore. Okay, so now we've created a Git repository, we can use it to keep track of changes made to our code base. So let's make our first commit. So Git tracks changes to files using 3 conceptual areas: a working directory, a staging area, and the Git repo. The working directory is where our code files are stored, and this is where we make changes to the code base. The staging area can be thought of as like a waiting room. Once we've made changes to a file in the working directory that we're happy with, we put those changes in the staging area. We can put changes to one file or many files here at the same time. Then when we've staged all the changes that relate to a particular update, we commit those changes and then they go into the Git repository. Now we refer to this as working with Git locally, because we're doing all of this on our local machine. when Git is used to interact with repositories on other machines, like using GitHub, then you're working with Git remotely. But today we're learning only about working with Git locally on our local machines. So now I'm done with the theory. Let's go back to our example. So far we've created a Git repository, but because we've not staged or committed any files, there are no files in there. And we can see that by running git status. So git status shows us we're on the main branch and there have been no commits yet. And then it's also telling us that there are 3 files, gitignore, license, and readme, that are at the moment untracked. So we've not added them into the Git repository. So before we can commit any files, I said we need to put them in the staging area, and we can do this by staging each file individually. So we just do git add and then git ignore. Because although git ignore lists the files that we don't want to be tracked, Git does need to know that file in order to know not to track those files. So the git ignore file itself needs to be tracked. And then we're going to do git add readme and then git add license. So now if we do git status, we'll see that those files have changed to green. So we're on the main branch, still no commits, but there are some changes to be committed. So Git now knows about those files because we've put them in the staging area, but they're not yet committed. So that's the final step. So to do that, we use the command git commit, and then we use the flag m, so -m, and in there we do a string where we put the initial commit for project. So you just put in whatever the reason is, and then we can see it tells us 3 files have been changed. So there are 3 insertions, and those 3 files have been added. So if we now do git status, I want to clear the screen. It's all a bit busy. So if we do git status now, we can see we're on branch main, nothing to commit, working tree clean. What that tells us is there's nothing in the working directory that we haven't staged, and there's nothing in the staging area that we haven't committed. So the working directory, the staging area, and the Git repository have all got the same version of all of the files. So we're all good. And it's good to do git status kind of before you start doing anything so that you know where you are. So get into the habit of doing git status a lot when you're working with Git repositories, just so that you go, right, yeah, so everything's up to date. So now I'm working on my new change. Now, if we do git log, we can now see the history of our repository. Just going to make the screen a little bit wider so it's not flipping over. So we've only made 1 commit. So there's only 1 commit listed here. So we've got commit, and then there's this very long number, and that's a unique identifier for that commit. So later on, when we want to hop between commits, that's the code we need to tell Git where we want to go. Then we've got that Claire made the change. I've got my email address. We've got when I did it, and then we've got the reason for the commit. So let's have a quick quiz on the commands that we've learned there. So we've learned git status, git log, and we've learned git add and git commit. So let's have a quick quiz on those. So making an initial commit. Okay, this. Oh, I need to take the answers off the screen. No cheating. Right. Making initial commit. There we go. Right, so give that a go. Thank you for telling me that I'm muted. I was just saying that my cat is meowing quite loudly outside because she feels she hasn't had enough lunch, and I wonder if you can hear her. She's a little bit distracting. I'm hoping somebody else in my house is going to give her some food soon. Okay, I'll just give you another 10 seconds or so. Thank you, Agatha, for letting me know you can't hear my cat. Okay, I think I've given you long enough there. So let's have a look at the answers. The answers. Here we go. So what command is used to view the current status of a Git repository? So that's Git status. That's the one that says, right, we're on branch main, there's nothing to commit, working tree clean, or it says you've got some changes in the working directory that aren't tracked, or it says you've got some files in the staging area that haven't been committed. The second question, what command is used to view the history of a Git repository? That's git log. Third question, what command is used to copy the changes in files? Everyone's got all of these right. Okay, so the command used to copy changes in files from the working directory to the staging area is git add, and then the command to copy changes from the staging area to the Git repo is git commit. So well done, everyone. Obviously paying attention, full marks. Okay, so let's move on to tracking changes for a single file. So remember that Git uses these three conceptual areas: a working directory, a staging area, and a Git repository. And we're going to remember that as we move through all of this. See, this has gone a little bit strange, and I don't know why. There we go. So let's open up the README file. So if I go into the file tree, I can just double click and open it up. And I'm just going to put a title in there. So you can put anything that you like in there, but I'm just going to put README as a title. So I've just made that change, just added a line, and then I'm saving that. So if I now, let's clear that screen, Squiffy. If I now do git status, it will tell me I've got changes that haven't been staged. So I've got changes in the README file that I haven't yet staged. And if I do, there's another useful command. If I do git diff, this shows me the differences between the files in the working directory and the files that have been most recently staged. Now, in this case, the files that have been most recently staged are the ones that are also in the Git repository. And so I've only changed one file, so there's just one file changes listed here. This can be a bit confusing when you first look at it because there's a lot of information there, but actually you don't need to pay attention to that much of it. So diff is telling me that it's the README file that has changed up here. That first line is telling me these files have changed. And then, and I've got here, the last line is a green line and there's some text in it. So it's telling me that that has been added. I've got one line added and it's README. So the old file didn't have that and the new file does. That is all that this is telling me. Okay, so now if I do, right, if there were lines in red, so green tells me that I've added text or code, red will tell me that I've removed it, and we will see that later. So now we've made changes in the working directory and we've had a check with git diff. We can see the changes and we go, oh yeah, that's happy. That's what we meant to add. That's what we meant to remove. We can now stage those changes. So to do that, we do git add and then the name of the file that we want to stage. And then if I do git status, we can see that's changed now. So we've got that we're on the main branch, we've got this change to be committed, so it's in the staging area, but it hasn't yet been committed. And if I did git diff at this point, nothing comes out. And that's because the working directory and the staging area are now the same. Because we staged the changes that were in the working directory and the staging area are now the same. So it's just important to remember that git diff is telling you the difference between the working directory and the staging area, not the working directory and the most recent commit. Okay, and that can be a bit confusing when you're first starting out. So it's just telling you the changes between the working directory and the staging area. So now we've staged that. Now let's commit it. So I'm going to clear the screen. It's got a bit crowded again. So to commit, we do git commit, and then we pass that M flag, and then I'm just going to put added heading to README file. Okay, so git commit with the M flag, and I've added the heading to the README file. It tells us we've got one file changed and one insertion, so it's just one line of text that was added into that file. And now, if I do git status, it tells me on branch main, nothing to commit, working tree clean, so everything is up to date. Now, when we do git log, we will have two commits because we've made two commits. So you need to know here, it's the most recent commit appears at the top, and then they're listed in chronological order going back in time. So the most recent commit is the one that we made here. So here I am, here's the date, and then I've added the heading to the README file. And then we've got the previous commit down here. And again, we can see that each commit has got this unique identifier for if we want to go back in time. So let's have a quick quiz to recap on the commands that we've been using. So first of all, I need to take the answers off the screen. Not going to make the same mistake again. And then go back. So tracking changes for a single file. So give that a go. I feel like the cat is upping her ante now. I can hear her outside the door. So I'll mute myself. Okay, I'll just give you another 10 seconds or so. And what you've missed out on is the cat coming in and then meowing at me very loudly, but now she's left because I am ignoring her. Okay, so let's have a look at those answers. Share those. Okay, so let's have a look. So what does Git status do? So Git status displays the status of the Git repository. So that's the thing that says, you know, on branch main, working tree clean, or these files haven't been staged, or these files haven't been committed. So that's what Git status does. The second question, Git log, that displays the history of the repository. So it gives us all of the, I mean, there's 100% there, and I have noticed I've left the answer over here. Okay, so that just lists all the commits that have been made and who made them, when they made them, and the reasons for them, and also the unique identifier for the commit if you want to go back in time. Git diff displays the differences between the working directory and the staging area. So it's important to remember that there are other flags that you can pass Git diff that's just beyond what I want to discuss today, because I'm just trying to keep it simple. So Git diff without any other flags just tells you the differences between the working directory and the staging area. If you want to see the differences between the staging area and the Git repo, you need to pass different flags. But actually, I don't generally do that, because I just want to see what I haven't staged yet before I stage it, so I know what changes I'm introducing into my repository. Git add, that copies changes from that are in the working directory into the staging area, which everyone got, and then the last one everyone got as well. So Git commit, that is copying the changes from the staging area into the Git repository. Brilliant. So now we can move on to tracking changes for multiple files. Not quite sure what is, well, okay, we'll just live with it like that. So you can't see it all on there. Okay, we're just going to have to look at it like that. I'll make the screen slightly smaller. That's all on there. There we go. So tracking changes to multiple files. So far, to keep things uncluttered, we just changed changes to a single file. And in practice, you'll probably make changes to several files at the same time when projects get more complex. So that's what we're going to look at in the final section. So first of all, we're going to clear the screen. We're going to do Git status, because that's what we always do before we do anything else on branch main. Nothing to commit, working tree clean. That's what we want to see. And this is make sure that any of our new changes don't get muddled up with previous changes. So let's make changes to a couple of files this time. So let's open up the license file. Oops. And so in here, I'm just going to add a title like I did to the README one. Like that. So just save that change. So just adding a title to license, and then README. I'm actually going to change a line so you can see what happens when you change a line. And then I'm going to add a new line as well. So this provides a detailed description of the project. Okay. Don't need 2 extra lines. So I've just changed that first line and I've added a second line, and I'm just going to save those. So if I now go back to the command line, which is going to be a squiffy again, I can do Git status. So that shows me that I've got these 2 files that I've made changes to and I've not staged those. If I do Git diff, this shows me the changes that I've just made. So we've got 2 files now. So there's 2 lots of this output. So the first one is telling me the differences in the license file. So I can see here there's 1 green line. So I've added the title license to the file license. And then the second lot of changes are to the README. And here I've got a red line and 2 green lines. Now, I changed README, the README title, to be README document. Now, rather than tell me that document had been added, Git actually works at a higher level than that. And it doesn't tell me what's been changed between the lines. It just tells me README line was removed and README document has been added. So that's the level of granularity you get there. You have to look yourself to see what the changes were between the two lines. So if you change a line, Git behaves as if you deleted that line and added a whole new line. It's important to know that. So we've got the README document line was added, and then another line was added as well. So these files can be staged separately, just as we did before with Git add in each of the file names. But then actually, I know that all of these changes I want to go. So there's a shorthand way of doing that. I could just do Git add and then pass a dot. And that just says all the files that are different in the working directory compared to the staging area should now be put, all those changes should be now put in the staging area. So Git add dot just does it quickly. So now if I do a Git status again, that. Those two files are now in green, so they've been staged, but they've not been committed. And so now I want to commit. So I'm going to show you what happens if you don't pass the M flag. So if I just do git commit, it opens up a text editor. So the way I've got Cloud9 set up at the moment, it's opening up, I think this is Nano. And actually, helpfully, it does tell me at the bottom how to get out of this. But if you want to write a longer message than just like a sentence, this is how you should do it. You open this up and you can put more information in here. Actually, I did this by mistake, and I just wanted to show you what happens if you do git commit and you forget to pass the M flag. This is what opens up. It tells me how to get out of this. Here's the exit here. So it's telling me to do Control X on my Mac. So if I just do Control X, it gets me back. And it says aborting commit because you didn't put a commit message. So that tells you you have to put a message in. Git won't accept a commit unless you put reason in there. So I need to start again. So I do git commit, I'll pass the M flag, and I'm just going to put something quick, added more headings. There we go. So added more headings, 2 files were changed, 3 insertions and 1 deletion. So I added 3 new lines. Actually, I just changed 1 line, but Git interprets that as deleting a line and adding a line. So that's why I've got 3 insertions and 1 deletion. So now if I do git status, where I want to be, branch main, nothing to commit, working tree clean. Just going to clear that and do a git log. Now I've got my 3 changes. The top one is where I am. And you can see all the 3 changes that have been made. So let's talk briefly about commit hygiene. So try to group your changes logically. Now, staging can help with this to separate out different updates you've made at the same time. So you can stage and commit them separately. So in the example we worked before, the change to README and license weren't particularly related. So if I did git add dot and I've staged all of those and they go, hang on a minute, I don't want to put them together. The staging area enables you to unstage one of them, which is what I'll show in the last workshop. But it's just make sure that you group your changes logically so you can unstage something, then commit what's in the staging area, and then stage the other file and then commit that. So I should probably have committed the changes to the license and the README file separately, and that's what we mean by grouping changes logically. Don't put loads of changes into a single commit. Try to stick with small self-contained updates to functionality, but do try to aim to have a working code base for every commit. So if you do go back in time, you will at least have a project that will run. It might have errors in it, but it will run and not just crash. When you're working on a project with other people that use Git, the most important thing is that everyone is singing from the same song sheet. So the project will have its own guidelines for commit hygiene, and you should follow those guidelines. Now, something I'm not going to show you today because it's just good to know what's coming up. But I just wanted to mention Git enables files to be unstaged before they've been committed. Like I said, that's useful if you've realized the update you've made has got an error or you don't want to include that in that commit. You can also reverse any changes that you've made in the working directory. And then best of all, Git enables you to use branching, which effectively creates a copy of your code base to experiment with. The experiment works, just merge that back into your main code base and continue on. If the experiment fails, you just scorch it and it doesn't affect your working code. You just go back to what was working and just carry on from there. That is for another time, but it's one of the incentives for making sure that you learn about Git. It's worth playing around with Git before you really need it, so that when you do need it, you know what you're doing. So that was the last thing. So summary, this is what we've learned. Let's just check. So there we go. I've really pushed to the limit what can be seen on this screen. This is what we covered. So you can see we actually haven't learned that many commands. It's 1, 2, 3, 4, 5, 6, 7, 8. So it's only 8 commands that we covered today. And the git config one, you only really need to use once when you're setting up. And the others are what we need to play around with. And the more you use them, the more you just remember. Don't worry if you didn't follow all of this. This was quite a quick run through Git. But hopefully it's made you more familiar with everything. And, you know, don't forget all of this information is in the Launchables Git and GitHub book, which is available free. You don't have to be a paying student to access those. So this is enough to get started. You need to practice, create a repository, change files, play around with it, delete it. All of this will become more familiar. Now, I'm sure that some of you will have to go because I have got to the hour mark. So I'm going to give a link to the feedback form again, but I do have another quiz for anyone that is keen for it. So let me know in the chat if you would like me to do that quiz. And then this also, sure, brilliant. I only need one person to say it, that's enough for me. So while we're doing those, if anyone's got any questions, put them in the Q&A and I'll be thinking about those while you do this last quiz. So here we go. Just going to launch that quiz. I shall clear the screen, so no cheating. Okay, so I'm just going to give another 10 seconds or so. And thank you all for being keen about doing the quiz. Makes me feel nice. Okay. Let's have a look at the answers. So if I end that, share the results. And open up the answers. So here we go. So the first question. On branch main, nothing to it, working tree clean. That's what we want to see when we do git status. That tells us we've got no change files in the working directory or changes files in the staging area. Everything, we've just done a commit, not made any changes. We're now ready to make our next lot of changes. So question 2, this one, this is what is output when you make a commit to your Git repository. So it'll tell you how many files have been changed and how many lines have been inserted, and it might say how many lines have been deleted as well. And it gives you a little, it gives you the commit message up there as well. So question 3, which command outputs that one? So this is git log, because it's giving us the unique identifier for the commit that we've made, and then who made it, when they made it, and the description of it. So that one's git log. And then the last one is question 4. So git diff. So this is when we've made a change to the working directory that we haven't staged. This is what will be output. So here, the change that has been made is that we've added, there's a green line there, so we've just added this contains all the information, ... So the only change, no lines were deleted, no lines were changed, we just added a new line, and that's what git diff tells us. That's what's been output there. So well done. So that's the end of the workshop. So I've answered all the questions that have come in as we've gone along, so that's good, unless anyone's got any more. So today, this is like a beginner's guide to version control using Git. Next time, we are going to be looking at GitHub. So that enables us to share our code and have a central repository as well. It's quite good for backups. So if something happens to your computer, if your files are on GitHub, then you can retrieve them off of there. And when you're working with GitHub, we refer to this as working with remote repositories. So come back next week and you'll learn all about that. So now all I need to do is say thank you. Thank you for taking part in the quizzes. I'm glad that you enjoyed it. I hope this was useful. You know, help future students by filling in the feedback form for me, telling me what works well, what doesn't work well. And one of the things I got feedback was don't chat while people are doing quizzes because it's hard to concentrate. So I hope I haven't done that too much. And today I've also learned I need to feed the cat before I do this at 4 o'clock in the afternoon because she's not impressed. So thank you, and hopefully I will see you all next week. Enjoy the rest of your day. Let's put the feedback form that I'm talking about here. Talked about it and I'm not put it in again. So I'll hang around while you grab that. But that's all for me today, and see you next week. Bye.